This is Chestacho.
The following information is drawn from the article titled First UK Baby with DNA from 3 People Born After New IVF Procedure, authored by Ian Sample and published in The Guardian on May 9, 2023. The birth of the first UK baby created with DNA from 3 people signifies a significant breakthrough in the medical field, more specifically in vitro fertilization IVF procedures. The baby's birth was the result of a novel technique known as mitochondrial donation treatment, or MDT, a process designed to prevent children from inheriting incurable diseases from their biological mothers. The MDT procedure incorporates tissue from the eggs of healthy female donors into IVF embryos, effectively eliminating harmful mutations that the embryo's mothers may carry and are likely to pass on to their offspring. The baby thus carries the DNA of the biological mother and father, as well as a small amount of genetic material, around 37 genes, from the donor. Despite the colloquial moniker of 3-parent babies, over 99.8% of the baby's DNA is derived from the biological mother and father. Pioneered by doctors at the Newcastle Fertility Centre in the UK, MDT, also known as mitochondrial replacement therapy, MRT, aims to assist women with mutated mitochondria to have healthy children without the risk of transmitting genetic disorders. This is particularly significant because all mitochondria are inherited maternally, meaning that harmful mutations can affect all children a woman gives birth to. The birth of a healthy child through MDT is a significant milestone, especially considering the risks associated with the natural conception for women with mutated mitochondria. Without the intervention of MDT, some babies may be born healthy by inheriting only a small proportion of the mutated mitochondria, while others may inherit more and develop severe, progressive, and often fatal diseases. Around 1 in 6,000 babies are affected by mitochondrial disorders. Mitochondria, often described as the batteries of the cell, are tiny structures that provide vital energy to the cells that compose our organs. When mutations damage the mitochondria, they tend to affect energy-demanding tissues the most, such as the brain, heart, muscle, and liver. These tissues can deteriorate relentlessly as an affected child grows. The UK Parliament acknowledged the promise of MDT and amended the law in 2015 to permit the procedure. 2 years later, the Newcastle Clinic became the national centre licensed to perform MDT. With the first cases approved in 2018, the UK's Human Fertilization and Embryology Authority, HFEA, grants approval for the procedure on a case-by-case basis and has given the green light for at least 30 cases as of 2023. The MDT procedure is complex and multi-staged. Initially, the father's sperm is used to fertilize eggs from both the affected mother and a healthy female donor. The nuclear genetic material from the donor's egg is then extracted and replaced with that from the couple's fertilized egg. The resulting egg carries a full set of chromosomes from both parents, as well as the healthy mitochondria from the donor, effectively replacing the mother's faulty mitochondria. Despite its success, MDT does not come without risks. Research has indicated that the small number of abnormal mitochondria that are inadvertently transferred from the mother's egg to the donor egg can multiply when the baby is in the womb. This so-called reversion or reversal could result in disease in the child. Despite being a pioneer in MDT, the UK is not the first country to produce babies through this procedure. In 2016, a US doctor announced the world's first MDT birth after treating a Jordanian woman who carried mitochondrial mutations that causes a fatal condition known as Lee syndrome. The MDT procedure represents a significant advancement in IVF and offers hope for families with severe inherited mitochondrial illnesses. However, due to the limited number of reported cases, it is too early to draw definitive conclusions about the safety or efficacy of the procedure. As such, continued research and long-term follow-up of children born through MDT are essential. It is also critical that the technology is used in a measured and carefully regulated manner to ensure the privacy and well-being of children with donated mitochondria and their parents. The birth of the first UK baby with 3-person DNA is not only a scientific breakthrough, but also a beacon of hope for those affected by mitochondrial disorders. It is anticipated that the future advancements and research in this field will continue to improve the lives of many families affected by these diseases.
This is Chestacho.